Journeyman Electrician Practice Test. Question 1. Conductors with underscore marked on the insulation are not approved for use in a wet location. The THHW, THHN, THWN. As shown in Table 310.104a, conductors with THHN insulation are approved for use in dry and damp locations only, and conductors with THWN, THHW, and the insulation are recognized for use in dry and wet locations. Question 2. Given, a one-family dwelling unit with a demand load of 200 amperes is supplied with a 120/240 volt, single-phase, electrical system from the local utility company. What is the minimum size aluminum the conductors required for use as service entrance conductors for this residence? 1/0 AWG, 4/0 AWG, 3/0 AWG, 2/0 AWG. Section 310.15, b, 7, 1, permits one-family dwelling 120/240 volt, single-phase, service entrance conductors to be sized at an ampacity of not less than 83% of the service rating. Therefore, 200 amperes x 83% equals 166 amperes. Table 310.15, b, 16, indicates size 4/0 AWG. The aluminum conductors with an allowable ampacity of 180 amperes should be selected for this dwelling. Question 3. Where a 150 kVA, single-phase transformer having a secondary voltage of 120/240 is installed at a multi-family dwelling, the full load current rating, in amperes, of the secondary is 625 amperes, 265 amperes, 526 amperes, 1250 amperes. To find the full load current rating of the single-phase transformer, apply the single-phase current formula as shown. I equals 150 kVA x 1000/240 volts equals 15,000/240 equals 625 amperes. Question 4. Which one of the following listed circuit breakers is not a standard ampere rating? 75 amperes, 90 amperes, 110 amperes, 225 amperes. Table 240.6a illustrates the standard ampere ratings for fuses and circuit breakers. A circuit breaker with an ampere rating of 75 amperes is not a standard ampere rating. Question 5. The minimum length of free conductor to be left at each junction box for the purpose of splicing conductors, or making connections to luminaires or devices shall be 4 inches, 10 inches, 8 inches, 6 inches. As per section 300.14, at least 6 inches of free conductor is to be left at each junction box for splices or the connection of luminaires or devices. The intent of this rule is to ensure enough conductor slack for the terminal connections or splices to be made easily. Question 6. In general, overhead service drop conductors shall not be smaller than 2 AWG copper, 4 AWG copper, 6 AWG copper, 8 AWG copper. Section 230.23b requires overhead service drop conductors to be not smaller than 8 AWG copper or 6 AWG aluminum or copper-clad aluminum. Do not get service drop conductors, the overhead conductors between the utility electric supply system and the service point, confused with the service entrance conductors, the conductors from the service point from the utility company to the service disconnecting means. Question 7. When a galvanized eye-bolt is to be used as the point of attachment for an electrical service, the NEC requires the eye-bolt to be installed not less than above finished grade, 8 feet, 10 feet, 12 feet, 15 feet. The intent of section 230.26 is to provide adequate vertical clearance of the conductors and prevent physical damage to the conductors and prevent persons from making accidental contact with the conductors, which may create a shock hazard or electrocution. In no case shall the point of attachment of the service drop conductors to be less than 10 feet above finished grade. Question 8. Why is electrical continuity required for metallic conduit? To reduce voltage drop, to limit galvanic corrosion, to establish an effective ground fault path and facilitate the operation of the overcurrent protective device, to reduce electrolysis. Electrical continuity is required for metallic conduit to establish an effective ground fault path and facilitate the operation of the overcurrent protective device. Reference section 250.4a, 4, and 5. Question 9. In dwelling units, receptacle outlets installed for countertop surfaces must be located above, but not more than above the countertop or work surface. 12 inches, 18 inches, 20 inches, 24 inches. In compliance with Section 210.52, c. 5, receptacle outlets installed for countertop or work surfaces in dwelling units may be located on or above, but not more than 20 inches, above the countertop or work surface. The intent of this rule is to eliminate the use of unsightly extension cords, which reduces the amount of usable countertop space on the countertop or work surface to supply cord-and-plug connected appliances. Also, receptacles located more than 20 inches above countertops or work surfaces may interfere with the cabinetry to be installed. Question 10. When conductors are installed in a conduit or tubing nipple of or less in length, the ampacity adjustment factors for more than 3 current carrying conductors in the raceway are not required to be applied. 24 inches, 30 inches, 36 inches, 48 inches. Section 310.15, b. 3a. 2, clarifies that adjustment factors for more than 3 current carrying conductors in raceways shall not apply where the raceway is not more than 24 inches in length. Where more than 3 current carrying conductors are installed in short lengths of conduit or tubing, the heating effect caused from the additional conductors is insignificant, therefore, the allowable ampacity of the conductors is not greatly reduced. Question 11. In compliance with the NEC, the total marked rating of a 120-volt cord-and-plug connected room air conditioner shall not exceed of the rating of a branch circuit when lighting units, general use receptacles, or other appliances are supplied from the branch circuit. 40%, 50%, 70%, 80%. Part 7 of Article 440 outlines the special provisions for room air conditioners which are 1. Rated not over 250 volts AC, single phase, and 2, which are cord-and attachment plug connected. In order to prevent overloading the branch circuit, as per Section 40.62 c, the total rating of the AC unit shall not exceed 50% of the rating of a branch circuit where lighting units, general use receptacles, or appliances are also supplied. Question 12. Which of the following shall not be located over the steps of a stairway? General use receptacles, overcurrent devices, switches controlling luminaires, junction boxes. Part 2 of Article 240 explains the permitted location requirements for overcurrent devices. Section 240.24 f tell us overcurrent devices shall not be located over steps of a stairway. This requirement addresses a serious safety issue. No one should be required to stand on different treads on a stairway to replace, repair, maintain, install, troubleshoot, or reset overcurrent devices in a panel board or switchboard located in a stairway. Question 13. Where a permanently installed outdoor swimming pool is located on residential or commercial properties, at least one single-phase, 125-volt, 15 or 20 ampere receptacle shall be located not less than from and not more than from the inside wall of the swimming pool. 6 feet, 20 feet, 10 feet, 20 feet, 6 feet, 6 inches, 10 feet, 5 feet, 20 feet. The provisions in Part 2 of Article 680 apply to the installation of wiring methods and equipment in or adjacent to permanently installed swimming pools, as confirmed by the requirements given in Section 680.22 a. 1. Each permanently installed swimming pool is to be provided with at least one single-phase, 15 or 20 ampere, 125-volt, receptacle placed not closer than 6 feet from the pool and not more than 20 feet from the pool. This requirement allows ordinary appliances such as a radio to be safely plugged in and used near the pool, but avoids the need for extension cords in the pool vicinity. Be advised the receptacles must be provided with GFCI protection. 680.22 a. 4. Question 14. Metal water pipes installed in or attached to a building or structure shall be bonded to the service equipment enclosure, the grounded conductor at the service, the grounding electrode conductor, any of the above. Part 5 of Article 250 covers the requirements for bonding of electrical installations. Section 250.104, A.1, requires metal water piping systems to be bonded to any of 1. The service entrance enclosure, 2. The grounded conductor at the service, 3. The grounding electrode conductor. Where mechanical and electrical connections are within equipment, a failure of electrical insulation can result in the connected piping systems becoming energized. For example, an insulation failure in an electrical circuit of a water heater could energize the metal water piping. Metal water piping systems must be bonded so that when a fault occurs between an ungrounded, hot, conductor and the piping, the potential difference between the two is minimized, thereby reducing the risk of electrical shock. Also, note where installed in or attached to a building or structure, all metal piping systems, including gas piping, that is likely to become energized shall be bonded to a grounded source. 250.104, B. Question 15. When armored cable, type AC, is installed in an accessible attic and is run parallel to the sides of rafters, studs, or floor joists, the cable shall be protected with running boards. The cable shall be protected by guard strips at least as high as the cable. Either A or B, neither guard strips nor running boards shall be required. The installation specifications for armored cable, type AC, are addressed in Part 2 of Article 320. Section 320.23, B, makes it explicit, where the armored cable is installed parallel to the sides of rafters, studs or floor joists, neither guard strips nor running boards shall be required to protect the cable in accessible attics. As per Section 320.23, A, if the cables run across the top of the floor joists in an attic that is not accessible by permanent studs or ladders, protection of the cable is required where within 6 feet of the nearest edge of the scuttle hole or attic entrance. Question 16. Generally, in a movie theater the manual switch for controlling the emergency lighting systems is permitted to be located in the motion picture projection booth, in an accessible location in the lobby, on the stage or platform, at any of these locations. The requirements of Article 520 apply buildings used as a theater or for a similar purpose. Section 520.8 mandates the control of emergency systems in theaters to comply with the rules set forth in Article 700. Part 5 of Article 700 applies to the control of emergency lighting circuits. Section 700.21 does not permit a manual control switch for emergency lighting to be placed in a motion picture projection booth or on a stage or platform. The switch shall be located in the lobby or at a convenient accessible location. Emergency lighting systems are designed and installed to maintain a specific degree of illumination for means of egress of the building in the event of fire, or similar emergency, or if the normal power supply fails. Question 17. Single conductor cable such as and single conductor cable listed and identified as solar photovoltaic, PV, wire are permitted for use in PV source circuits within the PV array, UF, THHN, Use 2, PVC 2. Part 4 of Article 690 covers the wiring methods specified for use on solar photovoltaic, PV, systems arrays. Section 690.31, C1, indicates open, single conductors such as type Use 2 and single conductor cable listed and identified as PV wire are permitted for use in PV source circuits within the PV array. These conductors are evaluated and listed for use where exposed to sunlight and wet conditions. Question 18. For dwelling units, GFCI protection is required for all single-phase, 125-volt, 15 and 20 ampere receptacles installed within 6 feet of the top inside edge of the bowl of sinks located in laundry rooms, bathrooms, garages, all of these areas. Section 210.8, A7, confirms that no matter what the location or room in a dwelling, where the 15 or 20 ampere, 125-volt receptacles are installed within 6 feet from the top inside edge of the bowl of the sink, GFCI protection must be provided to prevent a ground fault shock hazard. Question 19. For a building or structure where the meter enclosure is adjacent to the service disconnecting means, it is permitted to ground the meter enclosure to the conductor on the load side of the service disconnect if ground fault protection is not provided. Grounded, grounding, bonding, phase. Part 7 of Article 250 covers the general requirements for methods of equipment grounding. Exception number 2 to Section 250.142b permits the meter enclosure to be grounded by connection on the load side of the service disconnect where 1. No ground fault protection is installed, 2. The meter enclosure is adjacent to the service disconnecting means, and 3. The grounded service conductor is not smaller than the size specified in Table 250.122. Question 20. In a dwelling unit where a 125 volt, 15 or 20 ampere receptacle is located under the counter for an in-sink waste disposer, the receptacle must be provided with AFCI protection only, GFCI protection only, both AFCI and GFCI protection, neither AFCI nor GFCI protection. Because of the presence of water and grounded surfaces that contributes to a potential shock hazard, Section 210.8, A7, confirms any 125 volt, 15 or 20 ampere receptacle installed within 6 feet of a sink is required to be GFCI protected. Section 210.12, A, verifies AFCI protection is required for all 120 volt, 15 or 20 ampere branch circuits that supply outlets in kitchens and dwellings. AFCI devices are designed to determine resistance to unwanted tripping due to the presence of arcing that occurs in utilization equipment under normal operating conditions or to a loading condition that closely mimics an arcing fault. Question 21. Where a 125 volt, 15 ampere receptacle is connected to a 120 volt branch circuit supplying two or more receptacles or outlets, the maximum permitted cord plug connected load to the receptacle is 12 amperes, 15 amperes, 10 amperes, 7.5 amperes. Article 210 provides the general rules regarding branch circuits. Branch circuit and receptacle ratings are addressed in Part 2 of Article 210. To prevent overheating receptacles, a receptacle shall not supply a total cord plug connected load in excess of the maximum specified in Table 21, B2, where connected to a branch circuit supplying multiple receptacles or other outlets. This table shows a 15 ampere rated receptacle may carry a maximum cord plug connected load of 12 amperes under this condition. Question 22. In industrial establishments only, when a 200 ampere rated busway is tapped from a 600 ampere rated busway, what is the maximum permitted length of the 200 ampere busway where overcurrent protection is not provided for the 200 ampere busway? 100 feet, 50 feet, 75 feet, 125 feet. Part 2 of Article 368 governs the permitted installation of busways. For busways in industrial establishments only, providing overcurrent protection at the point where the busway size is changed is not required if the busway having the smaller ampacity does not exceed 50 feet in length and has an ampacity of at least 1/3 the rating of the overcurrent protection of the larger busway. 1/3 of 600 amperes equals 200 amperes. Reference Section 368.17, B, exception. Question 23. When installing non-metallic sheath cable enclosed in an underground buried PVC conduit, the cable must be type NMC, must be type NMS, must be type NMW, is prohibited. As explained in Section 300.5, the inside of all raceways and enclosures located underground is classified as a wet location. The conductors and cables installed in underground installations must be of a type listed for use in wet locations. Restrictions of the use of non-metallic sheath cable is addressed in Part 2 of Article 334. Section 334.10, B1, indicates type NMC is permitted in dry, moist, and damp locations, but wet locations are not included in this list. Section 334.12, B4, prohibits types NM and NMS cables installed in wet or damp locations. Question 24. According to the NEC, fixed outdoor de-icing and snow melting equipment is to be considered as a load, non-continuous, intermittent, continuous, simultaneous. As defined in Article 100, a continuous load is a load expected to continue for 3 hours or more. The installation requirements for fixed outdoor electric deicing and snow melting equipment are given in Article 426. As per Section 426.4, fixed outdoor electric deicing and snow melting equipment shall be considered a continuous load. When sizing conductors and overcurrent protection for the fixed outdoor equipment, you must take into consideration the equipment can operate over 3 hours, so it is considered a continuous load. Question 25. In regard to a commercial building, where a service entrance conduit having a length of 6 feet contains 4 size 2 AWG/THWN insulated copper current carrying conductors, each of the conductors have an allowable ampacity of __________, 92 amperes, 100 amperes, 115 amperes, 110 amperes. To solve this problem, first locate the conductor size on the left side of Table 310.15, B16, and look under the copper THWN column with a temperature rating of 75 degrees Celsius and note the ampacity of the conductors is 115 amperes. The table is based on an ambient temperature of 86 degrees Celsius and not more than 3 current-carrying conductors in the raceway. In this situation there are 4 current-carrying conductors in the raceway, therefore, we must apply the correct adjustment factor, derating value, as shown in Table 310.15, B3a, as follows: 2 AWG/THWN ampacity equals 115 amperes, before derating, 115 amperes x 80%, adjustment factor, equals 92 amperes.